Welcome to the Dusty Jobs podcast from Imperial Systems. Industry knowledge to make your job easier and safer.
Hello, and welcome to the Dusty Jobs podcast. This is our first episode of our third season, and we're excited that you guys are still with us. Today, joining us is Diane Cave from Element 6. How you doing, Diane?
I'm good, thanks. And you?
Oh, we're doing great. It's a little cold down here in Pennsylvania with the snow, and you're from up in Canada, correct?
Correct. I'm in Halifax, Nova Scotia, Canada, where it's probably colder today here. Yeah, it's pretty chilly. It's like minus 12 Celsius. So
yeah, we're not quite there. But thanks for joining us. We appreciate it. Not a lot of people might know you from our podcast, but you have done a lot of work and have been in the dust industry for quite some time. Is that correct?
Yeah, this year I have the big milestone of 20 years. So yeah. I don't know if that officially makes me old or not, but yeah, 20 years in the dust world. I don't really know where the time's gone, but
right. It definitely makes you a veteran in the dust world for 20 years. I'll tell you that much. So
yeah, for sure.
Yeah. So how did you get started in this whole thing 20 years ago?
So 20 years ago, I was a recent graduate at a university, and I was working at the customer service desk at Canadian Tire, which would be like Lowe's or Home Depot. And a guy came in, and he wanted to know if, this is a very random story, but it all plays in. He wanted to know if a spark plug matched the picture that he had drawn on this diagrammatic, so that he could fix his truck, his Bronco. And I was like, I don't know, man, like take it out of the package. And then he didn't want to. He threw the package at me, and I caught it with my left hand. And in Canada, I don't actually have mine on today because I burnt my hand, but in Canada, you wear an iron ring on the pinky of your working hand, and I'm left-handed. And so I caught it with my left hand. He's like, oh, you're an engineer. And then I made fun of him, and I was like, oh, aren't you smart? Da, da, da. And he hired me. And I worked for him for like 15 years, and then it was just kind of a decision. And what he did was combustible dust and dust collection and industrial ventilation, and so then it was just kind of a decision after I'd been there that kind of under his wing for however long, that I wanted to prove to myself if I could make it on my own 2 feet as opposed to always being under. So then about 3.5 years ago, I guess it would be, I left and went to Element 6 to kind of start dust adventure here. Yeah. And so I've been here since.
So that's a very different path to get into dust collection, but I'm not sure I've ever talked to anybody who had a real straightforward one, honestly. So it's a unique industry where people come from all different ways and shapes to get involved in it. So now you're at Element 6 though, right?
Yep.
So tell us more about Element 6. What is it? What do you do there? What's the company? Tell us more about what's going on there.
So in general, Element 6 is a much larger company than just the entity group that I work with. And the overall company, so we have an office just outside Toronto, Ontario, in Georgetown, one up near Ottawa, one in London, Ontario, and then here in Halifax. And I think we're starting one soon in the States somewhere. And as a whole, we're kind of a multifaceted engineering company that focuses somewhat more on the chemical industry. And we have a particular workflow that starts with 3D design and 3D scanning. So we'll start with 3D scanning and then develop it all from moving forward in the 3D world using all sorts of 3D packages. And we do like all sorts of mechanical, computational fluid dynamics and piping layouts and designs and pressure vessel stuff and then electrical and civil. So kind of anything and all. We do like big plant designs right down to smaller projects. And then the group that I work with here in Halifax, we just focus on dust. And we do kind of, I always say to anyone that, so if it involves dust, then we do it. So
Right.
starting with like dust collection system assessments or DHAs, right through to, like installation, commissioning, troubleshooting, design packages, finite element analysis for vessel strength to make sure
Right.
that to determine, which a lot of places don't do, is determining the P-red of a pre-existing vessel.
Right.
Yeah, hood design, which I just did my own personal plug, just did a webinar on.
Nice.
And yeah, and like training, so kind of anything and all stuff right across the board dealing with dust.
Gotcha. Now, do you guys focus a lot more on new projects, or do you focus a lot more on existing spaces? Which one would you say is more of?
It just kind of depends on what the client needs. Lately, it's been more so. Lately, it's been a whole lot of DHA stuff. Everyone trying to catch up with that DHA deadline because we've
Right.
far exceeded it. And then helping the end user, the client, figure out kind of where to move on next and how to implement the things that need to be in to be safe. But some new projects as well. Like lately I've been living my life in breweries. It seems doing a lot of work in breweries.
Yeah.
Has its pluses and its minuses. A lot of beer, but then there's a lot of beer. But I would say predominantly it's more existing systems or replacement of determining if an existing system is viable to like
Right.
go through a process change or something like that, and then upgrading it. That would be
So-
of what it is.
Yeah. So if I was a customer and I'm coming to you and I have an existing dust collector already, what are the things that I'm looking for, or what you would be looking for to say this is acceptable now for this combustible dust application, or it's not? Well, how do you guys actually go through and look at that evaluation? What would that look like step by step?
I guess so. The first thing would be to determine if they've got adequate collection, because a lot of times clients just want to our dust collector's worn out and we'd like to just replace it with whatever is already there. But
Right.
it's notorious in the dust collection world that everything is undersized because people are selling it to be the cheapest. But in the
Right.
long run, undersizing it just costs more money in the end. So the first thing is always to assess whether or not they've got adequate flow and collection for what they need, not for what is currently installed. And then from
Right.
they're going on and sizing to make sure that the ducting is sized correctly, and then make sure the dust collector is adequate for the application, and then looking at the fan to see whether the fan can do what they actually need, because more often than not the fan is grossly undersized in terms of static pressure requirements.
So a lot of what you're seeing first is possibly an undersized collector with an undersized fan, and then people are saying, why do we have problems? And you guys let them know it's because they have an undersized collector and an undersized fan.
Yeah, like there's a lot of forgiveness in with a system if your fan is oversized. And I'm not saying go out and oversize your fan, but if your fan is bigger than
Right.
what you actually need, there's a whole lot of forgiveness there, because it'll be pumping way more air through, so you're not going to be having problems with stuff collecting in your ducting. You'll probably get way better suction at your hood. So even if your hoods are designed poorly, your oversized fan will kind of make up for it.
Right.
And then even if you don't clean your dust collector, you have substandard, is that a polite way to say it?
Yes.
Substandard maintenance on your dust collector, and your static pressure gets high in your dust collector. Well, your oversized fan is going to take care of it. So
Still overcome that challenge.
yeah, well, to a certain extent. So if your fan
Right.
is oversized, then there's a whole lot more forgiveness in there. But more often than not, it's the bare minimum. So then the second you come into one little hiccup or one problem in the system, so your bags don't get changed or your cartridges don't get changed as often as they should, then that's just enough of a static pressure bump to then cause your fan to, the highly
Right.
technical term, crap out.
So I like what you're saying here. So if you're looking at an old system and you're having issues, it could be you have too small of a system, too small of a fan, and at that point, the thing that you guys might recommend is to go into a larger system or get a larger fan on that system. So if somebody out there is listening right now and they're thinking, man, these are some of the issues I'm seeing: dust settling in my duct, my filters, or everything's just underperforming. It could be those two aspects, right?
Yes, yeah. More often than not, it's I'm using that term more often than not a lot today. But the fan is a good place to start looking if you have problems, because it's the fan's a workhorse of the whole system, right? So if your fan's not sucking, then your system probably sucks.
Yeah.
You know what I mean?
I do. Or it doesn't suck, right?
Yeah,
That's the problem,
yeah.
right?
Yeah.
So that's one: size of collector, size of fan. So that's one of the things you look for. So you said ductwork layout. That's possibly another culprit that you guys look at. Is that correct?
Yeah. So a lot of people really like to run really small ducting really, really far. And what that does is it drives the static pressure up. So a lot of times, not everyone, a lot of people really like to just kind of, oh, we put this new piece of equipment in, we need dust collection on it. Oh, we'll just slap in a line.
Right. Yeah.
I'm sure you've seen it, where you end up then with like the octopus of ducting all over the place.
Oh, yes.
And there always seems to be one line, or somebody decides to use it as a vacuum system. Oh, let's just put this 1.5-inch hose on here, and then we can use it for housekeeping. And you'll look at it and you're like, well, that's what's causing the static pressure drive in the whole system. So if you just take and lop off that kind of one gangly limb that's hanging out all over the place, then a lot of times it can change the whole flow of the system. And then all of a sudden everything
comes back to life.
Yeah, I was gonna say perks up, but yeah, comes back to life, and then your flow can take off. So then if you kind of look at what the ducting layout is and what's going on, then you can a lot of times work with what's there. So it's not always, I'm not always a proponent of, rip it out, start again.
Right.
Because not everyone has first of all, you want to try and not throw as much stuff in the landfill as possible, but there isn't always the time, capital, or even ability to do it, to rip it all out. So it's, okay, well, if we change this or change that and we get rid of this ducting, or hey, if we just even improve these hoods, or get rid of as I always like to call them, the elephant trunks, which are just like hunks of duct. If you get rid of the elephant trunks and put hoods on there, that might even be enough to reduce your static pressure to then get your fan to bring it back to life, as you said.
Yeah. So we're looking at a system. We have a couple things that you've mentioned that you guys use to kind of troubleshoot or evaluate. What would be the thing when you get to a point and you're like, I'm sorry, this is it. Yeah, you have to change your system out. What would be a couple of those things that no matter what, the old one has to go and we have to get a new one? What would cause that?
I would say, and you mean like the whole, like, because it's kind of different for different things. So like if you're looking at the hoods and you're like, all right, these hoods have to be ripped out, because you just look at them and you're like, and they're doing nothing. They're in the wrong spot. They're they're held together with tape. Binding tape has many, many uses, and apparently one of them is to hold ducting together. And with ducting, I would say that to like go with the rip out and tear apart, or rip out and do again, would be that if it's really just slapped together, like if you look at it and you're like, okay, this, like, it's undergone a lot of morphing over the years, and has all kinds of new branches and lines, and there's never been any thought or care taken to it, and you just kind of stand there and you're like, it just has to go. It's just
So there might have been an initial design, but that has gone out the window years ago, and many things have been placed and put into there that shouldn't be there.
Yeah,
or were never initially considered.
Yeah, or if you're dealing with really combustible dust, and you've got spiral ducting, or really, really heavy loading or abrasive dust, and it's all spiral, and you're like, it's in your best interest, and you've got a poor design, then it's in your best interest to just replace it and then put in some smooth walled single seam ducting.
Right. Yeah, because that could, that spiral duct could potentially be a spark hazard, right?
Exactly. Yeah. Or even have an increase of static pressure, and because it all comes down to static pressure.
Right.
But yeah, it could be an increase for spark hazard, and then it's known that spiral ducting doesn't quite handle internal pressure as well. So if you do have some sort of deflagration event, you want to make sure that it doesn't unwind your spiral ducting.
Right. Right. So now we went from the hoods to the duct to the collector. So what would be something on the collector that you're just like, listen, this is one you're going to have to just abandon and get a new one?
If you can poke your finger through the side of it, that's usually the start. Or if like patchwork's been done where it's like, oh, we just tarred this whatever here, that's usually another sign. So like the physical appearance of it, if it's past gone, then you'll have to replace it. If it's a combustible dust application and there's and you're not certain of the vessel strength, so you do the vessel analysis on it, and you do like a finite element analysis, and it's just you're going to have to put way more reinforcing on it in order, like it's going to cost more to do the reinforcing
Right.
and to actually buy a new one. Then that's usually time to put in a new one. Or
If you're going to be building a new collector around the old collector, it's probably time to get a new one, right?
exactly, when you're like, well, we got to put on 1,000 pounds of angle on this sucker,
Right.
then it's probably not worthwhile. Or if the requirements of the air that are needed drive the air to cloth ratio to a really, really high level where it drives your static pressure up, or if it's a baghouse and you have a very high interstitial velocity or whatnot, where you're not certain if the dust collector will actually function for what the application is. You know what I mean? Where the dust won't fall out. Then it's usually time at that point to get a new one.
To get a new one, yeah. So you get to a collector and you determine that it is combustible dust that you're dealing with, and now the collector initially wasn't set up for combustible dust. How do you determine? You've talked a couple times about determining the vessel strength to see if it actually can handle that, and then what are the steps you do to do that, and how would you actually go about maybe trying to retrofit that collector? Because I know that's a little bit of a tricky area to do that.
Yeah, so the first thing, in terms of determining a vessel strength, basically, so we'll take a scan of the vessel, with our 3D scanners, and then I'll also, because the scan is good for overall bigger measurements, but we're looking for kind of precise stuff for size of bolts and bolt holes and whatnot. And you can likely get it with people will argue that you can get it with a scanner, but I'm a little bit old school in certain things. And then I know that we've got the information. So you go through and then make sure you get all the information, as in like the size of angles and where they are on the unit. And then we create a 3D model and do a pressure analysis on it. And then from there, determine what's going to go.
Right. Yeah.
and what it's going to hold. So we like to work to 2/3 yield, but it's not always the case. Excuse me, on some older vessels, you don't always get the option to then reinforce it to 2/3 yield. And so sometimes it's to 2/3 ultimate, and then it's just creating a package. So creating basically a design package that says, okay, well, this is where you've got to put your reinforcing and this is what you have to do. And there has been cases where we've gotten so far and just been like, you can't, like right. the pressures, the pressures that you want to get to, it's to the point of being ridiculous. Like,
right.
It looks kind of like, I don't know,
like a Mad Max version of a dust collector.
Yeah, I was going to say like the Shredder Technodrome or something like that from the Turtles. Yeah, like this is just unbelievably ridiculous, and you're like, oh, this is stupid. Right. and then you just kind of have to approach the client and be like, okay, so this is what it's going to look like ish. Like, do you really want to proceed down this route? And if they do, then okay, then we'll go that way. Or you end up being like, okay, well, we'll do it to 2/3 ultimate, and then knowing that the dust collector will be not usable, but we'll be able to make the changes needed for it'll be safe until you.
You're saying 2/3 ultimate, is that correct?
Yeah, so 2/3 yield strength versus 2/3 ultimate strength of the material. So the difference between it is that at 2/3 yield, you basically, if you have a deflagration event, and that's 2/3 of the material strength based on whatever your P red will be on
Right.
venting or your, I always get the letters wrong, TSP for suppression, basically your P red for for
Yeah.
suppression. And so 2/3 ultimate, you won't have deformation in your your vessel. So you can have an event, a deflagration that'll happen, but the dust collector would basically be like, all right, change the filter media, carry on.
Right. Yeah.
But with 2/3 ultimate, you'll have deformation, but not rupture. So
Gotcha.
your square dust collector might go from square to roundish.
Right. Right. Gotcha. So those are pretty important things to know.
And you'd be surprised. That's probably there's all kinds of things that you run into when you're at sites that people don't know, or end users don't know, because they're making whatever it is. So whether they make granola bars or tires or brew beer or whatever it is that they do, that's what they do. They're not aficionados in the world of dust collection and explosion protection.
Right. They don't have 20 years experience.
Yeah, so then that's why they bring in trusted consultants to handle all that.
Right.
But I would say that one of the biggest things that I see gets missed in terms of explosion protection is vessel strength. And so often you'll be like, oh, can I see the venting calculations for this? And then so you get the venting calculations, and they'll say that, it's the P red is, I don't know, I'm going to pick a number, 6 bar. And then you're like, oh, well, let's look at the vessel strength. And the vessel strength is, 2.9.
Right.
And you're like, oh, sorry, your P red, I got that, not bar, 6 bar, but 6 PSI. And then your vessel strength, your P red will come out to be like 2.9 PSI. And you're like, whoa, so the vessel's going to blow long before.
Yeah. It's not going to be able to contain the explosion or direct it in a safe way.
Yeah. And that's one of the biggest things that gets missed. And then people will just put vents on a dust collector without even thinking about, oh, well, it's got to be good. It's got to be good. And it's like, oh, this is basically, aluminum foil stretched over a frame. It's like, it's not going to hold any pressure. A big one is bucket elevators. So bucket elevators are supposed to be designed to a strength of like half a bar. And most of them are lucky if they do 1 PSI.
Right. Yeah. So they're just, yeah. So and this is all, I would say recently, more education on this. A lot more people are coming to this understanding. And unfortunately, it's probably been through a lot of events that have happened. But I think that's what's happened in the past, and it's helped get people closer to a safer work environment that goal is to get there every day, closer and closer to better, safer, so that people can go home to their loved ones at night because their dust collector didn't blow up. And I know that's what you guys are doing, and that's what we're trying to do here. So that's a little bit of the past and what you guys do. What do you think's going to be like the future as you guys are doing more of these DHAs and seeing what's going on out there? What's your finger on the pulse of where you think the industry's going and what people are doing?
What I hope anyway is, so as you know, in this world of dust collection, there's very few people that do it and do it well. And therefore it puts a demand. Well, I assume
Right.
and so, and therefore it puts a demand on a lot of people. And I hope that the industry is moving so that there's more knowledgeable people that understand things, like that.
Mm-hmm.
They don't just like sign off on stuff because it's like, oh, whatever, this will never happen. Yeah, sure, fine. That's where I hope the industry is going. And it seems to be that way, that there's more and more people that are taking an interest in, like, if we're dealing with combustible dust in terms of explosion protection and whatnot. There's more people aware and educated in that field. And I think it's because, like you said, there's been more incidents, and instead of,
Right.
and people wanting and the push to be in a safe work environment, as opposed to being like, oh, whatever, it doesn't matter, it's fine.
Right.
It blew up today, so it's not gonna, we got another 20 years before it's gonna happen again. Laws of statistics. And so I think that, though, I hope anyway, in terms of combustible dust, I hope that that's the way that the industry is moving, that because of education and awareness, because of things like this, where to bring the information to people, or like what Chris Cloney is doing, right, at Dust Safety Science. Right. So making people aware of what the hazards are, because I think a lot of it, in terms of dust collection, a lot of it so when I say dust collection, I also include like combustible dust in that umbrella. I think a lot of it is just education. And so the way I see it going is that people want to do the right thing now, as opposed to just wanting to check the box and wanting it to be whatever that, we just need a solution. Yeah, whatever, this will get us by for now. People are
right.
We want to do the right thing.
Yeah. Yeah. I see that too. I see a lot more people not just concerned about getting it done to check a box, but they are concerned with their workers and the health of the people around them and the health of the environment. Yeah. I think we've seen a lot of that change over the last 20 years, probably in the time you've been in this industry. There's been a lot of people changing in that regard, and it's good. I don't think, hopefully we don't go backwards at all in our industry. We continue to make things safer and cleaner for everybody who's involved, especially the people who are out welding or the people who are out working in those workshops, that we want to, help them have a better life.
Oh, for sure. But I don't see how it can go backwards.
Right.
Because going backwards would be, I don't know, getting rid of dust collectors, and then we just have
it
dust.
It would be insane.
Yeah,
right.
It would be. And I don't think the people working in those environments would let it happen in this day and age.
I think you're right.
I hope they would.
Right. So then we're both saying we're hoping for a brighter future with a safer work environment. I think that's what we're seeing.
I think that's where we're going, and I think a lot of things are pushing the trend that way, because people don't want their companies to be in the headlines. Company XYZ had an incident where whatever, they don't want to be the Imperial Sugars, for lack of a better way to say it. I mean, that's a bad way to analyze it, but that's what it is. They don't want to be that one in the headline that, we had
for negative things.
We had so many mortalities and however many, injuries on site because we,
something that's preventable, something that's very preventable.
Because we didn't have inlet isolation, or because, our explosion vents were pointed at the company daycare, which I've seen more than once. And
So, well, hey, Diane, we're so glad that you guys are out there helping people solve this, figure it out, and doing what you do. If someone's interested in getting a hold of your company or learning more about what you guys, or they've heard something here and they're like, man, she could really help me out, what would be the best way for them to get a hold of you?
You can Google me.
Okay.
I'll probably pop up. There's not too many Diane Caves out there. I'm on LinkedIn. You can email me at dcave@elmt6.com. You can give me if you our company website, which oddly enough I don't know off the top of my head, which is probably,
we'll put a link to your website in the notes for the podcast. So if anybody's listening or on YouTube watching this, they can just look at it there. So we'll do that for you. Don't worry about it.
Perfect, because I was like, I'm not sure if it's Element 6 Solutions or if it's shortened down, or should have remembered that beforehand, but
it's not a big deal. It's not a big deal. I'm sure if someone Element 6 dust collection, they'll figure it out. Explosive dust, it'll come up.
And if you Googled it and put in Element 6 dust collection, you'll probably find me.
Yeah, we'll find you guys. So, well, hey, I just want to say thanks so much for coming on. We really appreciate it. Hopefully we get to talk to you again sometime, because I feel like we just scratched the surface of the knowledge you have. So, but if you're interested in learning more about us here at Imperial Systems and Dusty Jobs, you can follow us on YouTube, Instagram, Facebook, Twitter, or learn more about us on our website. So thanks for listening to everyone out there, and stay healthy, stay safe.
Thanks so much. Thanks for having me.
Thanks for listening to the Dusty Jobs podcast. Breathe better, work safer.